Hello, everybody. Today we're on Unit 5, Lesson 4, Finding Zeros. So we're still in the polynomial unit. If we take a look at our do now, if f of x equals 2x cubed plus 11x squared minus 7x minus 6, and you're asked to write the function in factored form and identify the zeros, we'd begin looking at this problem, and you always start by kind of taking a look and seeing what you have. So I have 4 terms. So I would most likely try to use factor by grouping. And when I go and look at factor by grouping, I notice as I look along these terms, I have no GCFs. So I'm kind of at a loss. Yesterday, we were able to start someplace. So, what's the matter with this problem? What do you notice? We can't factor this by any of our known methods. We don't have a place to start. Yesterday, we were able to break it apart because we had something, we were given something, and they said, is this a factor? And once we knew it was a factor, we could move along from there. Today, we don't have that. So what we're gonna do today is, I should have read this. Yesterday, we were able to find the zeros, both real and complex. And just as a little side note, complex is just another way to say imaginary. So when you get a negative under a square root sign, okay, you know that's an imaginary root. You know that's going to be an I. So we were able to use the factor theorem. We were given a factor to start with. Today, we're going to learn how to factor a polynomial when we have no place to start with. Think about this. If we go back up here, if we wanted to find a zero, of course we could cheat and go into the calculator, which is what we're going to do anyway. But we'd have to start plugging in numbers and see which number gives us a zero. So we're going to learn about a theorem today. It's called the rational zeros theorem, and it's a method used to find possible zeros, assuming you don't have a calculator to work with. So basically, when we're setting up or using the rational zeros theorem, we're going to identify and use P as the factors of the last term. And then Q, we'll use those, we'll make the factors of the first term. And then we're going to set up a ratio of all of those factors. So we're going to go back to our original do now. If I start with my original function, 2x cubed plus 11x squared minus 7x. I just want to write it down a little bit lower. 2x cubed plus 11x squared minus 7x minus 6. Now remember, we're going to let P be the factors of the last term and Q be all the factors of the first term. So P, think about it. What numbers multiply together to give you 6? So we have 1 times 6 and 2 times 3. So I'm going to list those factors. That's all I'm doing. And then I identify my factors of Q. Q is easy. It's just 1 and 2. Now, when we create our list of possible zeros, P over Q, we're going to include every positive and negative version of them. So I'm going to set up my ratio. And by the ratio, I mean 1 over 1, 1 over 2. 2 over 1, 2 over 2. So plus or minus 1 over 1 is 1. Plus or minus 1/2. I move on to the next plus or minus 2 over 1, which is just 2. Plus or minus 2 over 2, well, that's just 1. It's already on the list. I don't have to recount it. Plus or minus 3. Plus or minus 3/2. Plus or minus 6. And now plus or minus 6 over 2 is going to be 3. And again, it's already on the list, so I don't have to count it. And now what we've done here is we've created a list of possibilities. Basically, the theorem is if x has a rational zero, if x has a root that's a rational number, it will be on this list. So we took the narrowed down all x's to a list of 12 possibles. That's all. That's all the rational zeros theorem does. It takes your whole x values and says it's got to be one of these. Now, how would you decide to pick what number from this list? This is where it gets tricky. Okay. You'd have to plug each of these numbers in. Again, we're kind of thinking that we don't have a calculator. Plug each one in until you get a 0, right? Our hint, always start with 1 or -1. Now here's where we're going to get, because of the technology we have, we're going to kind of steer away. We have to teach you about the rational zeros theorem, but we're going to steer away and make things quicker. And so in this course, we're going to cheat and use our calculator. So I'm not going to ask you to do, f of 1, f of -1. I'm not going to ask you to go through the list. We're going to take this and we're going to plug this guy into our calculator. And I don't know, I have to find my calculator. All right, so I have my calculator here. I'm going to put in my function. So I go into y equals 2x, what is it, 2x cubed plus 11x squared minus 7x minus 6. 2x cubed plus 11x squared minus 7x minus 6. So I have my function in my calculator. Now here you could go one of two ways. I like to look at the graph, and I like to look at what's going on there. I wonder if I can, oh, I can't. Oh, sort of I can. Okay, so I'm looking right here. It looks like x equals 1, which is on my list, can be used to help me factor. It also looks like that possibly it could be -1/2. It's very hard to see with this calculator. So a better way, if you're using your calculator, might be to go to your table. And I see if I plug in 1, I do get 0 as an answer. What else? Oh, see, -6 would also work. See, when you plug in -6, but why use a -6 when you can just use 1, which is a lot easier to work with? So we're going to go back over to our lesson, and now we're going to take our function. Right, we had 2x cubed plus 11x squared minus 7x minus 6. And we're going to use x equals 1 as our divisor there, which means x minus 1 is a factor. 2, 11, -7, -6. I'm dividing by 1. Remember, this is synthetic division. You already know how to do this. 13, 6, 6, 0. So basically from our previous work, we know that using 1 as our number means x minus 1 is a factor. And then I'm left with my reduced equation, 2x squared plus 11x, 2x squared plus 13x plus 6. And I'm going to now see, can I factor this? Now I have a trinomial I'm trying to factor. And I know I can use, I did something wrong. No, I didn't. Okay. So I know I can use my tricky trinomial factoring. X minus 1 is still a factor. We're not going to worry about that. I'm going to set up my 2 sets of parentheses, 2x, 2x. I want to find two numbers that multiply to 12 and combine to give me 13. And that's going to be 12 and 1. I put in a factor of 2. I have to divide that away. So my function in factored form is x minus 1 times x plus 6 times 2x plus 1. And this would be the factored form of my function. It factored quite nicely and easily. My zeros are 1, negative 6, and if you had to work this out, most of you can see it in your head, and negative 1/2. Now we're just going to go check back up at the beginning that we found my power, my degree is 3, so I should find 3 zeros. I found 3 zeros. They happen to be all real numbers. Sometimes they're going to be imaginary. That's okay. I have 3 zeros on my list, so I'm completely done with this problem. I have my factored form and my list of zeros. Let's just go back to the picture really quickly. Okay. If we go back and look at our graph, we kind of match. That's my 1, that's my negative 1/2, and that's my negative 6. So it is, it does sort of match up. Some helpful hints when you're given an equation. We should have done this first. I'm a bad teacher, but we should always identify the maximum number of zeros you're looking for. Then you're going to use the rational zero theorem, but I'm only going to make you do this step if asked. Okay, so if you're working through a problem and I don't tell you to list all the zeros, you can jump straight to the calculator. Put a f of x in your calculator and pick a 0. Use synthetic division to help you factor, and then identify all the zeros. Remember, a complex just means it's an imaginary, and you had to use the quadratic theorem, the quadratic formula, and you wound up getting a negative under your radical. So we're going to work through a couple of examples together. I'm going to go a little bit quicker here. Okay. For this one example, I am going to use the rational zero theorem one more time. Okay, I am going to make a list. So the first thing we want to do, our maximum number we should find is going to be 3, okay, because that's the degree of the function. Now I'm going to set up P, Q. P is the factors of the last term, 1 and 3. Q is the factors of the first term, 1 and 2. And now I'm going to set up my ratios, plus or minus 1, plus or minus 1/2, plus or minus 3, plus or minus 3/2. All I did was set up a ratio out of each of those numbers. Now I'm going to plug this in my calculator and pick one of the numbers from my list. I'm going to make my calculator big. It's easier for me to see. Clear out the function, put in your new function in y equals 2x cubed minus x squared minus 4x plus 3. Double check that I have it right because I'm known to make mistakes. Check out the graph. Okay. And on the graph, I see it looks like, this graphing calculator is so hard to see on. Looks like it could be 1, I don't even know what numbers are. Maybe 1 and negative 1.5, so 1 and negative 1.5. But I'm going to double check and I'm going to see if, yes, 1 does give me. Okay, when I plug in 1, I get 0. It's a lot easier to see on your regular graphing calculator. If you want to use that instead, that's fine. Okay. So we're gonna pick 1, right? We're gonna use positive 1. And I'm gonna take, and I'm gonna set up my synthetic, right? So we're using x equals 1 to start. 1, negative 4 plus 1, And when I break this down, I get x minus 1. Remember, this number we divide by is always set up as a factor. I'm left with 2x squared plus x minus 3. And we want to continue this. So we're going to look at our trinomial and see if we can use our little cheating method, right? Tricky trinomial. Two numbers multiplied to -6 and combined to give me +1. Yes, this should work out. 2x, 2x. So I have +3 and -2. I put in a factor of 2, so I have to divide out a factor of 2. X minus 1, 2x plus 3, and x minus 1. So basically, I know I'm just rewriting it stupid, but that's okay. So this is my factored form. And if you notice, x minus 1 occurs as a factor twice. So you could rewrite it like that. Okay, you definitely could rewrite it like that. When I'm finding the zeros, I may want to break it up like that, because then it's a lot easier to see that that 1 occurs as a 0 twice, meaning it has a multiplicity of 2. And x equals -3/2. So my zeros, 1, 1, and -3/2. And we were supposed to find 3 zeros. We have 3 zeros on our list. And from our graph, it's easy to see that, okay, when we look at the graph of this function, that the factor of 1, it bounces there. That's why it has a multiplicity of 2. And our other x-intercept is -3/2. Okay? So hopefully you're seeing the connection between all the things we've been studying over the past couple of days. This one's going to be a little bit of work here, guys. Okay, so we have 3x to the 4th plus 5x 3x to the 4th plus 5x cubed plus 25x squared plus 45x minus 18. The maximum number is 4. Okay. So this time I'm not going to use the list, okay? Because the factors of 18, there's so many. I'm going to be winding up listing so many things when I'm just going to go to my calculator and cheat anyway. So we're going to go clear out the calculator. 3x raised to the 4th. Cubed plus 25x squared. And we're going to graph him. And I see I have one that's probably going to be a weird kind of fraction one. I'm going to kind of see if this is on the list. So I go to my table and I look at my negative values. And I see when I plug in -2, I get 0 as my answer. So I'm going to use -2. Right? I'm going to use -2 to help me factor. 3, 5, 25, 45, -18. 4, 3, 2, 1, 0. Okay, so I just wanted to make sure I didn't have to skip anything. I'm using -2, -6, -2, -2 times 3. There's my mistake. I knew I made a mistake. 5 minus 6, negative 1, positive 2, 27, negative 54, negative 9, positive 18, 0. Sometimes you just make stupid mistakes and you have to go back and fix them. So I have x plus 2. Remember, if we're using x equals negative 2 as our x-intercept, then x plus 2 is the factor we're dividing by. And we're going to be left with 3x cubed minus x squared plus 27x minus 9. And we're factoring this guy. So I look at this, 1, 2, 3, 4. I'm thinking I can use factor by grouping. I'm hoping I can, because it's a lot easier. Group the first two, group the second two. X squared, 3x minus 1, plus 9, 3x minus 1. I go through, I'm just going to go a quick check. I can't factor anything any further. So this is my function in factored form. And from the factored form of the function, we could go ahead now and identify our zeros. So we got x equals negative 2, but we already knew about that one. And now we have x equals 1/3. And when I go to set this last factor equal to 0, I see I have x squared equal to negative 9. When I square root both sides to solve, that negative under our radical sign gives me plus or minus 3i. So now this, in this example, my zeros are negative 2, 1/3, and plus or minus 3i. If you notice, we did get 4 zeros. 2 of them happen to be imaginary. So when we look at our graph, we're only seeing 2 zeros that are x-intercepts and 2 don't show up in the picture. Okay. So it does match. So here's my factored form, and here's my list of zeros. One more example, and we should be done for the day. F of x equals x to the 5th. Oh, that's a biggie. So our maximum number of zeros, we're looking to find 5 zeros total. I'm definitely not listing the factors of this one. Remember, the rational zeros theorem was used more before we had calculators. Okay, we still teach it for the concept, but we're going to definitely make our life easy with the technology we have. X to the 5th minus x to the 4th minus 4x cubed plus, x to the 5th If we happen to be in the classroom right now, I'd probably let you work on this one independently. But we will go through this together. X to the 5th minus x to the 4th, 4x cubed, 8x squared, minus 32x plus 48. Okay. So basically that's what my picture looks like. I could zoom in if I want to. Okay, so my function's there. I'm using these x-intercepts. I'm looking at those. I think 2 might work for me. I'm just going to double check. Nope. Oh, yes. When I plug in 2, I get 0. So I'm going to start with x equals 2. What do you notice about that 2? That bounce there. What do you think is going to happen? The factor x minus 2 is going to occur twice, but we're going to talk about that in just a minute. Going back to my work over here. I'm using x equals 2 to help me. 1, -1, -4, 8, -32, and 48. 2, 2, -4, 8, -32 plus 8 is -24. Oh, thank God this worked out. So basically what we did, I took and I divided out a factor of x minus 2. And remember, we've got to put these powers back in. Always start 1 degree lower. I started at x to the 5th, x to the 4th, plus x cubed minus 2x squared plus 4x minus 24. Now I'm going to focus on this. When I look at it, the first thing I always try to do, 1, 2, 3, 4. I can't use factor by grouping. I don't have any other method. When you don't have any other method, you have to use another round of synthetic division. So we're going to go back to our original. And pick another 0. We already saw from the graph that x equals 2 has a multiplicity of 2. So rather than go try to figure out the negative one, I'm going to use x equals 2 again. This time I'm going to take the coefficients here. I'm going to use these coefficients for my second round. 1, 1, -2, -2, 4, -24. 6, -2 plus 6. I get a remainder of 0, which means it worked out nicely. X minus 2. I started at 4, divided out another factor of x minus 2. So I have x cubed plus 3x squared plus 4x plus 12. Now, remember, we have to account for this guy and this guy. X minus 2, x minus 2. Now I can use factor by grouping. X squared, x plus 3, plus 4, x plus 3. So my factored form is x minus 2 squared, x squared plus 4, and x plus 3. There's your factored form. So I'm going to go over here to find my zeros. X minus 2 squared, x squared plus 4, and x plus 3. And we're going to set that equal to 0 and solve it. We saw from above, x minus 2 just means that there's that factor occurs twice, so I have to count it as 2 zeros. X squared plus 4 equals 0. We're going to get x equals plus or minus 2i. Remember, when there's a negative under the radical sign, it's just an I. And here we have x equals -3. So my zeros, 2, 2, -3, plus or minus 2i. 1, 2, 3, 4, 5. We were supposed to get 5 to begin with. We did. Only 3 of them are real. Only 3 of them cross the x-axis. But again, we don't care. That's okay. This is our factored form. This is our list of zeros. Okay. We're not going to worry about this question. We've done enough today. Thank you for joining in, and we'll be back tomorrow.